Okay, here we've got a curve, we're given its equation. It talks about a stationary point, though that doesn't come into play until part B. We've got to start out just by finding dy by dx, so this is your chapter 5 rule for differentiation. 3 marks looks very generous. They will give plenty of marks the first time you have to differentiate something. There are 3 terms to deal with. Getting your correct answer for dy by dx shouldn't be a problem if you follow chapter 5. Hence, that means using what you've just done, we've got to find the x-coordinate of M, which was the stationary point. Stationary point is a code phrase. It gives you a bit of a hint here because it says hence, so we need to be using dy by dx. dy by dx equals a particular value at a stationary point, and that's your starting point. Use your expression for dy by dx to set up an equation, solve it, and find the x value of for which there's a stationary point, and that's all you need this time. It just wants the x-coordinate, so you don't need to find the y-coordinate of n this time. In part C, find d2y by dx squared. That means you differentiate your dy by dx again, so operate your chapter 5 rule again, and this time there's only 1 mark because you've already proved you can differentiate. Hence, or otherwise, so use what you've just done to determine whether M is a maximum or a minimum stationary point. So we're going to be using d2y by dx squared. Your notes in chapter 6 will remind you of how to interpret the value of it, but you do need a numerical value, so you need to substitute an x value in to your d2y by dx squared, and it's relating to the point M, so you need to know the x-coordinate of M, which you've got. Then in part D, you've got to determine whether the curve is increasing or decreasing. This is a re-entry point. All this stuff about the stationary point you can forget about. We're away from M now. We're at a different x value. X is 0. Increasing or decreasing. Once again, chapter 6 will remind you about how to interpret something for that. It turns out to be not to do with the second derivative or to do with y, something else you need to look at with x is 0 to decide whether it's increasing or decreasing. So put in the x value into that thing and draw a clear conclusion, and you should get this 2 marks.